Hello friends, welcome back to my channel Technical Arquen. Myself Arnab Kundu. In today's video, we are diving into the world of machine learning with the most powerful and easy to understand machine learning model, linear regression. And also using Google Colab, I will write and run Python code step by step, no setup needed. So let's begin the hands-on journey with machine learning in action. Okay. So friends, today I will discuss the machine learning in action and one of the most powerful and easy to understand the machine learning model, linear regression. Okay, and using Google Colab, I will write and run the Python code step by step, and in that case no setup needed, right? So at first we should know what is linear regression. Linear regression model is based on the equation of straight line, okay, where y equal to m dot x plus c, where x is the input feature, y is the predicted value or output, m is the slope or the coefficient, and c is the intercept, right? The linear regression is used for predicting the continuous numerical value, right? Linear regression is a type of supervised learning where data sets are leveled. Example, suppose we find out the price of a flat based on the square feet, right? Today I will describe the problem to predict the price of a flat in lakh based on square feet, right? So predict continuous value by this linear regression is concerned, right? And the key concepts for today's problem is concerned, we already know the core steps of machine learning. So I have already discussed in my previous video the core steps of machine learning program is concerned, like import the libraries, the load or create the data set, like that. Okay, so the key concept for today's problem is concerned the data split. We already know, split the data set into two parts. One is the training and is the testing. Also train the model and then use to evaluate the model. We are using two different loss functions. One is MSE, the mean square error, and R squared score functions, right? And after that plotting the actual and the predicting value using some visual representation, right? So go to my Google Colab workspace. I will discuss today's linear regression model with a proper example step by step. Okay, so I'm just within my Google Colab workspace. So I have already written the program here, and now I describe the problem step by step, means the core steps of the machine learning program I will describe step by step. So at first, the first step is that import libraries. So these libraries are needed. Pandas, these libraries or module needed for data manipulation and analysis. NumPy, this module is needed for numerical operation and arrays, and Matplotlib and submodule pyplot is needed for representing the visualize result, right? And this sklearn, this sklearn module is most popular Python library which is used for machine learning task, because whatever the task we are doing step by step, every cases we need this particular module named sklearn, or also known as scikit-learn. Okay, so second step is that we create the data set. So our problem is that to find out the price of a flat based on the square feet. So some square feet and the price in lakh given as a data set is concerned. Then we create the data frame object. Okay, and now the third step is that define features and the target. What happened? For basically in machine learning model is concerned, where capital X is known as the input feature and small y is known as the target value or predicted value. Okay, and for any machine learning model where especially the scikit-learn or sklearn library is used, the convention is that for this capital X is actually the independent variable, it represents the featured inputs. Okay, small y is the dependent variable which represents the predicted value of the output. And just see here given capital X equal to df and we are using 2 square bracket. Why? Because this capital X is usually a 2D array or data frame, and where this small y is usually a 1D array or series. So that's why we are putting this double square bracket to represent a data frame with a column. That's why it's a 2D, right? Now the step 4 is that split the dataset. We already know when it's splitting the dataset should be in the 2 part, one for training and another for testing. And for that case we are using here 4 variables. One is x underscore train, y underscore train. This pair is used for the training, and x underscore test and y underscore test, this pair is used for testing. X underscore train represents the input feature for training, and y underscore train represents the respective outputs for training, and x underscore test represents the input features for testing, and y underscore test represents the respective output or predicted value for testing, right? And this particular function is used for split the dataset train underscore test underscore split, which is a part of this sklearn module, right? And then we sent argument x, capital X and small y, and then we are using here test underscore size equal to 0.2. That means the division is in that way, the 80% go for training and 20% go for testing for overall dataset is concerned. Okay, random underscore state equal to 42. It ensures the same split every time, means ensures the productizability of the result. This 42 integer we are using here have no specific technical reason. We can use any integer value between 0 to 99. Okay, for ensuring the same split every time, random underscore state equal to some integer value. Here the convention we are using as a 42, right? Now the 5th step is the train the linear regression model. Now we train the model, so we call this linear regression. Train the linear regression model, so use here linear regression, this model here, and now we fit the model with the training value x underscore train and y underscore train, and then we make the predictions, and the prediction is done by the tested value. That's why we are sending the x underscore test, which is the input features for testing, right? And then we are evaluating the model using 2 loss functions. One is MSE, mean square error, and R squared score. These 2 different functions are used to evaluate the model. Lower MSE value indicates better model performance, and for R squared score value near to the 1 means it is the best fit for the model is concerned, right? And then after that we just print the result, whatever the value for MSE and whatever the value for the R squared score. Okay, then we plot the result in a visual format using this Matplotlib and this pyplot module is concerned. So scatter diagram we are used here, plot the data within that, after that leveling in x-axis put the square feet, y-axis put the price in lakhs, and title given flat price prediction, because our problem is that to predict the price of the flat based on the square feet, and then we just show the result in visualized format. And the 9th step is that predict price for a new flat size. What does mean? Actually for testing is concerned, we put the input features, but this input feature is unknown and new, but these values are present within the data set. Okay, but for this predict price for the new flat size, whatever the square feet we are sending here, this is totally new, which is not present within the data set. Actually what happened for the dataset is concerned, when we divide this dataset into two parts, 80% go for training, 20% go for testing. So when we test for this particular make prediction is concerned, we are doing the prediction using the unseen input features, but this unseen input features present within the dataset. Okay, and for the training is concerned, when you put the training is going on, the model learns from that pattern, and from that pattern they predict the result for the unseen input features which is present in the dataset but not present in the training set. But here what happened, when we predict price for a new flat size, means new square feet we are provide, this data is not present within the data set, means totally new, not even present within the data set, right? And then it will predict the price of that flat is concerned, whatever the square feet we provide here. Okay, so now we just execute this code, just press this button, and now it will take some time to train the model, evaluate the model, and display the also the plotting result. Okay, so just see the mean square error is okay, it's very low, that means it's a better model performance. R squared score is near about 1, that means it's also the best fit for that. And this is the representation of the visual representation of the data. Just see, this is scattered data, whatever you are provide as a data set, and it just put the straight line, because we already told this linear regression is based on the equation of the straight line. So that's why we put the straight line here. This is the regression line is concerned. This x-axis contain the square feet and the y-axis contain the price in lakhs. So this is the flat predictions visualization data, and it's predict for 1950 square feet what will be the price of the flat, near about 78.95 lakhs. Okay, I hope you have understood today's video. Today's video I just put the flavor of linear regression model, which is one of the most powerful model of machine learning is concerned. And when we do some machine learning, then we should follow all the core steps, the load the libraries, then create the data sample, then we go for splitting, then go for train the model, then predict the result from some unknown data, but this unknown data present in the data set, then evaluate the model, and also we visualize the data through some representation of the graphical representation, and also predict totally new data which is not present within this data set. If you have some doubts for today's video is concerned, just write in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical Arcane for more videos. So today up to this. Thank you and bye bye.